All right, now let's go find the derivative of log base a of x. So we know that this can be rewritten as the exponential statement a to the y power is x. So let's go take the derivative with respect to x. So the derivative with respect to x of x is just 1, and the derivative with respect to x of a to the y is a to the y times ln of a times the derivative of y, which is y prime. All right, so from this statement here, if I solve for y prime, I get 1 over a to the y ln of a, and what's a to the y equal to? X. So I get that the derivative, so if I've got derivative of log base a of x, it's 1 over x ln of a. Let's contrast that with the derivative of a to the x, which is a to the x times ln of a. So make sure you have the two separated. They're close to each other, but not quite. If I have a g of x in there, I carry that g of x along, and then I multiply by the derivative of it afterwards. So you know ln of x is the same as saying log base e of x. So if I was to take the derivative of log base e of x with my new rule, it's 1 over x ln of e, but what do you know ln of e is? 1. So that's why this is true. So if I derivative of ln of something else, ln of stuff, it's 1 over stuff times the derivative of stuff. And we're just going to get used to this notation, 1 over u, u is a function of x, times the derivative of u with respect to x. It doesn't matter if there's an absolute value in the ln before you take the derivative. There is no absolute value here in the answer. Make sure you know that. If I have the derivative of the absolute value of g of x, there's no absolute value in this answer either. Make sure you know these log properties. They're really important. So if there's multiplication there, it's addition here. Division here, it's subtraction. And this exponent can come down. And I want you to make sure that you never do this really bad math. Whoops, ln of b. So this is wrong, to separate it around the addition in the middle. Very, very wrong. Or a subtraction. So ln of a minus b does not equal ln of a minus ln of b. Really, really wrong. Okay, so let's go to it. I'm going to find this derivative. I have the 1 over the function times the derivative of the function. And that's it. All right, that's for ln. Okay, so here's log base a. So the derivative will be 1 over the function. And then I'll have ln of the number, always ln of the number, and times the derivative, which is 3. All right, so let's find this derivative. 1 over the function, so 1 over this ln of x, times the derivative of ln of x, which is 1 over x. All right, so here's the absolute value in the original problem. So the derivative will be 1 over 5x to the 4th plus 4 times the derivative of 5x to the 4th, which is 20x cubed. Okay, so this log properties do not apply, so this can just be rewritten as ln of t to the 1/2 power. So to find the derivative, first d second plus second d first. So I guess you could simplify this a little bit. So this would be t2 square root of ln of t plus 2t square root of ln of t. All right, this properties do apply. So this can be rewritten as ln of t to the 1/2, and since the 1/2 is just on the t, this second one can be rewritten as this. So if I wanted to really make it nice, there we go. So I have product rule to do, where I can carry the 1/2 along. So this is first function, derivative of the second, which would be 1 over t, plus ln of t times the derivative of the first, which would be t. So again, I could simplify this a little bit. So I get t over 2 plus t ln of t. Okay. What do I have here? Looks like I have quotient rule, and I could do quotient rule. I could rewrite this as chain rule. So the first one, I'm going to leave it as quotient rule. This one here, I could rewrite this as ln of x to the negative 1 if I chose. Again, log properties do not apply. I would just have to do chain rule on that one. So let's go do quotient rule. Low d high minus high d low, square the bottom and off you go, minus, and then I'm going to bring this negative down, so it turns into a positive 4, ln of x to the negative 2 times 1 over x. Cleaning this up a bit. So I would have plus 4 over x ln of x squared. All right, so let's play with this one because I think there are log properties that can make this problem much easier. So this x cubed, can come down in the front. So this is the x cubed is the angle of the e, so it's x cubed ln of e minus, and let's go slow with this one, so this is the same as saying ln of pi minus ln of x, and then this plus e, and I'm going to take the time to rewrite this as x to the negative 1 before I take the derivative, because you know e over x, right, is the same thing as saying e times 1 over x, e times x to the negative 1. Okay, so you know ln of e is 1, correct? So let me do one more simplification. I'm going to distribute this negative through. So I get plus ln of x plus e to the x to the negative 1. Okay. All right, so that's times, I should say. I said it wrong. Okay, so the derivative will be 3x squared. ln of pi is a number, so the derivative of that is 0 plus 1 over x plus derivative of e to the stuff is e to the stuff, and then take the derivative of that, so I'd get negative e x to the negative 2.